Welcome all to Vectors Class 14. In this we'll discuss about direction cosine. So direction cosine means assume that we are having a vector. Let's say this vector I am representing on xy plane, something like this. XYZ plane like this. So just remember that it is not in two-dimensional plane, it is in three-dimensional plane. So over here we can say that this vector is making some angle with respect to x-axis, just say that is represented by alpha, and this vector is making an angle beta with respect to y-axis, and this vector is making an angle gamma with respect to z-axis. Actually it is in a 3-dimension, so we can imagine that it is making an angle alpha, beta and gamma with respect to x-axis, y-axis and z-axis respectively. Then this cos alpha, cos beta and cos gamma are known as nothing but its direction cosine. So I'll discuss why this cos alpha, cos beta and cos gamma. Like if you are having a vector, let's say along this direction, and with respect to x-axis, if this vector is making an angle, let's say that is equal to alpha. So we can find out the component of this a vector along the direction of x-axis. So component of a vector along x-axis can be written as nothing but a cos alpha. Same as like that, if the same vector, let's say a vector, is making an angle, let's say beta with respect to y-axis, so we can find out the component of this a vector along the direction of y-axis, that will be equal to nothing but a cos beta. Same as like that, this vector, let's say a vector, making an angle gamma with respect to z-axis, so we can write the component of a vector along z-axis will be equal to nothing but a cos alpha. So we can write, if the actual vector is represented by a vector is equal to x I cap plus y j cap plus z k cap, we can write this a vector is equal to, this x component is nothing but a cos alpha, and this y component can be written as nothing but a cos beta, and z component can be written as nothing but a cos gamma. So this cos alpha, cos beta and cos gamma are known as nothing but direction cosine. So we can find out this cos alpha is equal to, as a cos alpha is representing the x component, we can write cos alpha will be equal to x divided by a, and cos beta will be equal to nothing but y divided by a, and cos gamma will be equal to the magnitude of z component by the magnitude of vector. So you can write down the notes. If a vector in space makes an angle alpha, beta and gamma with the x-axis, y-axis and z-axis, then cos alpha, cos beta and cos gamma are called direction cosines. Now one more important relation is, if you are squaring and adding this direction cosines, that means if you are going for cos square alpha plus cos square beta plus cos square gamma, then this will be equal to, cos alpha was nothing but x divided by a, cos square can be taken as x square divided by a square, plus cos beta is nothing but y by a, so we can write cos square is y square divided by a square. Same as like this can be written as z square divided by a square. So this can be equal to x square plus y square plus z square divided by a square. Over here our actual vector was a vector is equal to x I cap plus y j cap plus z k cap. So if you are finding out the magnitude of this vector, or you can write the value of a square will be equal to x square plus y square plus z square. Or you can write, instead of this x square plus y square plus z square is nothing but a square divided by a square. So I'll get the value is equal to nothing but 1. So just remember that if you are squaring and adding this direction cosines, you will get the answer as nothing but 1. Hope so that you understood what is position vector. If you are having any doubt, or if you'd like to interact with me on live classes, or if you want to write online tests for JEE Mains, Advanced or Neet, or if you want to solve more number of questions to improve your performance, please let me know, and don't forget to subscribe this channel. Thank you.